Have you ever really thought about it? You open up your browser, you grab an extension, maybe an ad blocker, a PDF viewer, whatever, and poof, your browser suddenly has these new superpowers. It really does feel like magic, doesn't it? But how does that actually happen? How is it all possible?
Well, the secret isn't actually magic. It's something much cooler. A really elegant design called the microkernel, or, as you might guess, the plugin architecture. And trust me, once you get what this is, you are going to start seeing it absolutely everywhere.
So today, let's pull back the curtain. We're going to demystify this whole concept and see exactly how it keeps our software so flexible, so adaptable, and honestly, just way easier to manage.
All right, first up, the power of plugins. To really get why the microkernel is so brilliant, we first have to look at the problem it's designed to solve. We need to see what the world looks like without it. And that world can be, well, a total mess. This is what we call the brute force method. It's what happens when you try to cram every single possibility into one giant piece of code. You end up with this tangled disaster of if-else statements. Just imagine you're writing code to handle different phones. It's like, if it's an iPhone, do this. Else if it's an iPod, do that. Else if... Every time a new phone comes out, you have to dive back into that core code, add another else if, and just pray you don't break everything in the process. It's brittle, it's messy, it is a developer's absolute nightmare. So how do we get away from that nightmare? There has to be a better way, right? Well, there is. And this is where our hero, the microkernel, enters the scene. At its heart, the whole idea is actually beautifully simple. You just split your application into two main parts. First, you've got a basic core system. This thing does only the absolute bare minimum. And then you have a bunch of independent plugin components that bolt on all the extra features. And here's the thing. You already get this. You really do. Just think about your web browser again. The browser itself, that's the core system. It does the basic stuff, right? It handles tabs, connects to the internet, draws the pages. But that ad blocker you installed, that's a plugin component. And because that plugin's code is totally separate, it's not just easier to update, it's also way safer. If that extension has a bug, it probably won't crash your whole browser. Okay, section 3, the core and its crew. So we've got a core system and this crew of plugins. Let's dig a little deeper now and see how this team actually gets the job done. So, the core system. The absolute most important rule here is that the core stays lean. I mean, really lean. A perfect example is something like the Eclipse IDE. When you first download it, the core is basically just a simple text editor. That's it. And that minimalism, that's its superpower. A lean core is super stable, it's easier to test, and it gives you this rock-solid foundation for all the powerful stuff, like compiling code or managing Git, which all get added on later as plugins. Okay, now think back to that messy if-else code we saw earlier. The microkernel way is, well, the complete opposite. It's so much cleaner. When the core gets a request, let's say assess an iPhone 6s, it doesn't actually know how to do that, and it doesn't need to. Instead, it just checks the central registry, finds the right plugin for an iPhone 6s, and just hands off the job. The core isn't the one doing the work. It's more like a traffic cop, just directing requests to the right specialist. And that brings us to the plugins themselves, the specialists in this operation. Each one is its own little standalone independent module, built for one specific job. And this independence, this is the key to everything. It means a developer can work on one plugin without ever having to worry about breaking another one. You can add brand new features without ever touching that stable, reliable core. That just reduces the risk of things going wrong by a huge amount. So you might be asking, how does the core even know which plugin to call? Well, that's where the registry comes in. The best way to think about it is like a phone book or a contact list, just for plugins. And this thing is totally dynamic. When you install a new plugin, it just adds its phone number to the book. When you uninstall it, its entry gets ripped out. This is what lets the system grow and change over time without needing a total rewrite.
Of course, for all this to work smoothly, everybody has to be speaking the same language, and that's where contracts come in. A contract is really just a set of rules. It defines exactly how the core and the plugins are allowed to talk to each other. I love the analogy of a universal power outlet. The contract is that standard wall socket. As long as your new plugin is built with the right prongs, the core system knows it'll fit, knows how to give it power, and knows it won't blow a fuse. It's what makes sure everyone plays nicely together.
Okay, that's the theory. Now for the fun part. let's look at some surprising real-world uses of this architecture. You're going to see it in places you probably didn't expect. So we've already touched on web browsers and developer tools like Eclipse. But this pattern is the secret sauce behind some absolute powerhouse apps. I'm talking about Jenkins, which automates software development, or Jira for project management. Both of them have a solid core, sure, but their real power? That comes from the huge, massive ecosystem of plugins that let you customize them for pretty much any workflow you can dream up. But it's not just for tech products, not at all. Think about something like insurance. The rules for an insurance claim can be completely different from one state to the next. So instead of building one gigantic tangled program, insurance companies can use a microkernel. The core system handles the basic claim process, the stuff that's the same everywhere. And then each state's unique rules, they live in their own separate isolated plugin. So if a law changes in California, you just update the California plugin. You don't touch and you don't risk breaking the logic for New York or Texas. It's brilliant. And it's the exact same idea with tax software. You know how tax laws are always changing? It's constant. So what they do is treat each tax form, like a 1040 or a Schedule C, as its own little plugin. That way software companies can just add, remove, or update those forms as the laws change. They don't have to rebuild the entire application from the ground up every single year. It makes the whole system unbelievably adaptable. All right, final section, the architect's scorecard. So this architecture sounds amazing, right? But look, like any big design decision in software, there are always trade-offs. It's not perfect. So let's break down the pros and cons with a little scorecard. And this scorecard tells a really interesting story. On one hand, you see 5 stars for simplicity and cost. And that makes sense, right? Because at the end of the day, it's still just one single straightforward application. But, and this is a big but, that very same simplicity is the source of its biggest weaknesses. Look at the bottom, only 1 star for scalability and fault tolerance. Why? Because everything, and I mean everything, depends on that central core. That makes it a single point of failure. If that core system crashes, the whole app is dead in the water. So you get this amazing flexibility with the plugins, but you're always bottlenecked by that single monolithic core. So, what's the big takeaway from all this? The microkernel architecture is just a fantastic tool for building systems that need to be flexible and adaptable. It's the reason our software can evolve without completely falling apart. From the browser you're probably using right now to the most complex business software out there, it's quietly working in the background. And it kind of makes you think, doesn't it? If you could add any feature, any plugin to your favorite app, what would you build?